All right, we should be live for Roll Quant office hours. Okay, let's think people are signing in or trickling in for Roll Quant Unit 2 office hours. I see Ramsey. Welcome back, Ramsey. Okay, I'm going to start prepping some stuff here. If I go into data course and go into office hour, I'm going to replicate this notebook, duplicate it, because we left off in a middle of a discussion. So I'm going to go and rename this. Open up that notebook. I see Kudu. Nakudu is here. Vedant. Sulaiman is here. Welcome everyone to Roll Quant 2 Unit 2 office hours. Second office hours we've had. And we had a pretty good discussion yesterday about expert systems and kind of where machine learning fits in the whole picture. We had an introduction into machine learning and how it fits into artificial intelligence. And just as a recap, machine learning is one way to create an artificial intelligence system. One way. The other way is an expert system, machine learning versus expert systems. And expert systems was one in which we hard-coded a set of rules. And required, quote, an expert to come up with those rules. But the problem we had there in this expert system was this idea that for an expert system, those rules might change with time, that we're not able to make use of data directly to improve those rules. And machine learning, on the other hand, is a program, or you think of it as an algorithm, that can take the data and absorb from it and learn some pattern, pick up some pattern, identify patterns, and use those identified patterns in its intelligent task. So that was the recap between artificial intelligence and the expert systems versus machine learning. So we're going to focus all about machine learning in this course. And the Python package we'll be playing around with throughout the course is scikit-learn. I would say one of the main goals of this course, one of the main goals of this unit, is proficiency with scikit-learn. I want you to be able to feel very comfortable using this tool. Not only that you know how to use it, but you feel very comfortable and you feel like you know it in and out, so to speak. That's really one of the goals for this unit. I see Badgasen is here. I see Fatima. Welcome back, Fatima. I see Nancy. Hello, Nancy. I see Ray Dot. Nice to see you back, Ray Dot. I see Ramsey's asking, should we be learning ML algorithms? And we are going to learn ML algorithms as we go through this curriculum. So scikit-learn makes it very easy for one not to know what is going on underneath the hood, which is sort of the goal of any kind of package or any kind of software, right? The whole goal of any kind of software or packages is to let you worry about other things and it to worry about implementations. So in some sense, scikit-learn, you can get away with so far with what's happening underneath the hood in these ML algorithms. However, I think knowing how these algorithms work, and to a certain deep level, not to be knowing the ins and outs and the nuts and bolts of them directly, but knowing how they work at a high enough level was going to go a long way in how you utilize these models. So you can get away with not knowing them, but you might be able to not really exceed your potential until you gain proficiency and understand what's going on with those models. So in fact, as we go through the curriculum, there's going to be videos explaining how those models work underneath the hood. And as we explore these models, we'll be asking ourselves questions about what are the time complexity of these models. Yes, this is Unit 2. What's the time complexity of these models? What is the hyperparameters of these models? We'll be asking and probing questions as we go through the curriculum about what's going underneath the hood so we can know that we can properly use these tools. So yes, we should be learning ML algorithms. We'll be learning them throughout the coming weeks. I see a couple other familiar faces. I see Taiwo. I see Mickey Rat. Welcome back, Mickey Rat. I see Derajay. Joseph. Welcome, Joseph. This is Unit 2. You're more than welcome to stay. I'm not going to kick you out, so to speak. I see Akafor. Hello, Akafor. Description is written as Unit 1. Oh, I see. I have written Unit 1 in the description. Oh, that's a typo for me. I should go ahead and... I thought I edited that. I thought I made an edit to it. Let me go ahead and hit the refresh button, because I do see that. I do see it's listed as Unit 1 for some particular reason. So let me go ahead and edit that. I think I see what's happening. Let's see. It's an entirely different URL for some particular reason. I don't know what's going on. Why that happened. Oh well, these things happen. Let me see if I can make change this edit video. Let me quickly make an edit, and I will change this to Unit 2 and save. And then we go back to the stream. Now it says Unit 2. Now it says Unit 2. All right. Thank you, Mohammed, for pointing that out. I made the fix. You're more than welcome to stay. I won't kick you out. Okay, I see Ramsey saying, can you suggest some resources for basic overview of algorithms and maybe which algorithms we should focus on for now? Besides our curriculum, I guess, I can point out to a couple resources, and let's see, I can, let's see. There's a free book called An Intro to Statistical Learning. I can post this here. This will explain, go in depth about those algorithms. I think the more important algorithms you should know, understand decision trees and tree-based models. If there's one set of algorithms that you want to know pretty well, I would say tree-based models. Decision trees, random forest, and gradient boosting trees. That's what I would focus on. All right, so do Unit 1 students leave the live stream, or is it necessary for us? I mean, nothing is necessary in life, right? So you're more than welcome to stay. No one's holding you back. Right? If you go into Unit 1, right? Unit 1 has, right, your pods always will have the office hours, right? If you go there, you go into your pod, it has the time for office hours for Unit 1. So there should never be any confusion about what time Unit 1 and Unit 2 office hours are, because they are on your pod. Of course, I can log into the pod for Unit 2, go into video links. Never a question when office hours are, but you're more than welcome to stay. Nothing is required in life. Okay, all right. Let's go ahead and crack this open. And we were having a discussion about this idea of estimators. There's a question. We didn't quite finish this discussion. I want to keep on with this thread people were asking about in office hours. In Scikit-learn, we have this idea of estimators. And estimators are simply a class. We can object that class. And estimators are simply models. General term, estimators are just models that get fitted, that get trained. And there are two, broadly speaking, type of estimators. There are transformers, and there are predictors. We have transformers and we have predictors. And transformers are models that are built to transform data. In our workflow, in our EverQuest to come up with a predictor, by the way, is a model that makes predictions, learns from data, makes predictions. Transformers learn from the data, apply a transformation on that data. In machine learning, very rarely do we have a data set and we could just feed it into an ML algorithm or just feed it into a predictor. There's several steps that you must work with the data for the final predictor. This whole idea of garbage in, garbage out still applies in machine learning. So it's very common that you have a workflow, multiple steps, going from raw data to a final refined product. And that product would be a set of predictions. Someone's asking about Unit 1. If you go to their pod of Unit 1, bingo, there is a playlist. Right? This is Unit everything that you want to know. Most 95% of your questions are answered through this homepage. Video links, office hours playlist. Make sure you use your URL for Unit 1. You've got that answered. All right. So if I continue on with this, let's go ahead and play around. Let's go ahead and run that cell here. I'm going to import a data set. I'm going to examine this data set. And then one of the things I want to do is I want to have a two-step process. I want to scale my data. So my workflow is I want to scale my data. And then followed by a predictor. This is my workflow. So what is this scalar here? What is it? Well, if I look at my x, I'm going to calculate the average of each column. It's a NumPy array, so I'm going to mean. This will compute the average of the entire array, but I just want to compute the average for each column, the average down the rows. And that's what I do there. I calculate the average down the row. So this is the average for each of my features. A feature is a column. It's a characteristic. X of shape, 8. Here are my 8 means. And notice how each one varies, has a different value. Right, I have 4, I have 29, I got 5, I got 1, I got 1,000, I got 3, I got 35, I got negative 100. Notice how each of these features exists on a different scale. Something as small as a scale of 1, as high as 1,000. In these ML algorithms, a lot of the ways the way they work are implemented are very sensitive to the scale of the features. They are not going to work right if your features exist on widely different scales. You can still arrive at an answer. You can still have a model that works, but it may not work well. So we got to do some sort of pre-processing to get our data ready. In this particular case, we need to scale each of our features so that they have a similar scale. So they range from, let's say, -1 to 1 mostly. So if they all exist within similar scales, then our ML algorithm can better use and learn from that data. Yeah, so we're going to have to use some sort of scaling. There are various different types of scalars out there, but we're going to play with one called standard scalar. So from sklearn, pre-processing, import standard scalar. And what the standard scalar would do, if I look at the documentation, right, when we pull out the documentation, great documentation, standardize features by removing the mean and scaling to unit variance. So in other words, it's going to take my feature, take a given feature, x, minus the average for that feature, divided by the standard deviation of that feature. So given this scaling, if it's normally distributed, most of my points will exist between -2 and 2. right? Statistically speaking, if it were Gaussian, 95% of my values will range from -1 to 2. So if you apply this scaling, then all my features should hopefully all reside in a similar scale. So let's create a scalar object. That's what I do there, create my scalar object. Let's go ahead and fit that scalar object with my data. I fit it. Well, what does it mean to fit the scalar? Well, if we think about it, in order for us to apply the transformation, we must learn what is the average and standard deviation of each of the features. We must learn from that of the data. That information is contained in attributes, scale, and mean. So notice how these attributes end with an underscore. Notice these attributes end in an underscore. In scikit-learn, attributes of models that end in an underscore mean that they are only populated and created after the training process. So of course, we only know the mean because we fit it. In other words, we only know it after we called fit. We only know the scale after we fit it. So that now that we fit any questions so far, any questions people have before I proceed? Is there a method to print out attributes of an estimator other than looking up the documentation? There is. You can say dir. Dir is a function in Python that will return to you all the attributes of an object. So that's what you would do without looking up the documentation. If you have autocomplete, right? If you have autocomplete, you can hit dot and then see that there is another possibility. What explains it again? What's fit mean? Fit means that we train the algorithm / model. In other words, is we use the data to learn and determine some set of parameters. So generally speaking, fitting just means we have calculated a set of parameters that from the data that we will use later on. So in our data set X, I can calculate the average for each column. I can calculate the standard deviation of each column as well. So this is when I fit the model, this is what it's doing. Underneath the hood, it's calculating the average of each column and the standard deviation of each column. Because with these two sets of values, it can then transform the data. So fitting a model means we're going to learn from the data, calculate something from the data, so we can store those parameters and use them for transformation or use them for prediction, depending if we're a transformer or a predictor. So I could, right? I could do it myself. I can transform the data myself. I could do it myself, or I can let the transformer do it. Is mean SCD it's from NumPy. It's from NumPy because the type of X is a NumPy array. So scikit-learn is built on top of NumPy. In other words, the way it works is assuming the data has a NumPy array underneath the hood. In fact, you can give it things that are not NumPy arrays, and it will try to convert it into a NumPy array. So here we did it manually. Manually so to speak, but this is what's happening underneath the hood. So that when I say scalar.transform of X, it's running the calculation. So when I do transform of X, here it takes the two things it learned from the data, which in this case, which are the standard deviations and the means. And it uses those to transform the data. And yes, as always, I post these office hours notebooks on the shared drive. Don't forget that. If you go to video downloads, office hours notebook, I post these notebooks after the fact. So you will have these notebooks available after the fact. They're a little bit messy because they're sort of ad hoc when I create them through office hours, but you will have access to these. No worries. And now I can transform the data, and I can assign that to x of t. That's what I have there. Questions or follow-ups people have? How can we know if we should use pipeline or a feature union? It depends on what you're trying to do. Are you trying to string two estimators in series? You use a pipeline. If you're trying to string, not necessarily string, but if you're going to have two estimators in parallel, transformers in parallel, you use a feature union. Feature unions are a way to have two transformation steps occur in parallel. A pipeline is to string together in a series two estimators. Does transform always take SCDs and means? No. Transform is a general. Transform doesn't take anything. Right? I didn't give. It takes the data. Transform is just a generic term. It's a generic method for all of these different transformers we have. This is one particular type of transformer. There are various transformers in scikit-learn. And it just so happens this one we're using learns the standard deviation and the mean. It learns the mean and standard deviation from the data so you can transform it. So you can apply this scaling, this standard scaling. So what I'm here I'm demonstrating a transformer that is in scikit-learn is going to scale my data. And what is the reason behind that transformer in our data? The reason behind it is because, as was mentioned earlier, these predictors, these ML algorithm predictors, they can be rather picky about the data. And they wanted it to all exist in the same scale. If I have features that go from 1 to 0 to 1, 1 to 100, 1 to 3000, all these widely different scales, I can still create an ML model, but it may not work so well. So one thing I need to do is I need to do some pre-processing. I need to make sure that my features that go into the model have been scaled such that they all have similar scales. They all reside within the same scale. And scikit-learn provides this is called a transformer. It transforms data. It's a way to pre-process the data. And one such transformer that we played around with so far is called standard scalar, that learns the mean standard deviation and uses those learned parameters to apply the transformation. Questions and follow-ups before I move on. We got more questions coming up here. Why scalars take only the mean standard deviation when transforming? Well, that's just a definition of scaling. That's a definition of this scaling. That we're going to scale it by, we're going to subtract the mean divided by the standard deviation. That's just the definition of the scalar. That it needs the mean and it needs the standard deviation. So that's all it needs. That's all it needs. So we got to make sure that we learn these two sets of parameters from our training data. So when do you decide to use standard versus min-max scalar? So Mickey Rat is pointing out the fact that, hey, in scikit-learn, there are more than one way to rescale the data. There's standard scalar, but there's also one called min-max scalar. In fact, let's play around with that. From sklearn, pre-processing, let's import min-max scalar. And let's look at what that does. It's going to transform features by scaling each given feature to a given range, which by default is 0 to 1. So if we look at the equation here, it looks like what it needs, if I look at this documentation, it looks like the way it's going to scale the data is it's going to calculate the max and min. So this is a different way to scale. It will calculate max and min. Then it will first come up with an intermediate transformation, which is x minus max over min minus max minus min. And then it comes up with the final transformation, which is max times min plus min. Plus min. So it's a different way to scale our data. It's going to calculate the max and min of each feature and use these max and mins to scale the data. So let's play around with it. Let's play around with this one. Let's see what results we get. So we're going to say, I'm going to say scalar min max is equal to min max scalar, scalar min max. Let's call fit on my data. And now let's look up those attributes. It's got one called max, and it's got one called it's got something probably called max as well. Min max. Not min, I want max now. Ooh, it's not called that. Let's see, it's called data max, I guess. And let's see what this is called, data min. And it uses these to scale the data. There they are. There's the thing that's learned from the data. Remember, well, what's happening here, this transformer, it takes the training data and it learns something from it. It calculates something that it needs for the transformation process. So that now it can calculate that. So now it knows these two things. Then it can undergo the transformation process. So I can say x of t, scalar transform my x, and now I have my transform data set. So it's a different way to scale my data. Now the question is, as Mickey Rad is pointing out, when do you decide to use one over the other? I'm going to get to that. Let me take a look at the chat here. The last mini project Unit 1 asked us to return scaled values, so now we're going to use scikit-learn and not pandas numpy to perform. Yes, exactly. We're going to use scikit-learn to do it for us. The reason being is because, as we'll see later, if we stay within the scikit-learn infrastructure, we can use all the tools that are compatible. If we start mix and matching things, and let's say we do pandas here, we do numpy here, we do scikit-learn there, it becomes rather difficult to glue all those components together. So if we stay within the scikit-learn infrastructure, the scikit-learn environment, the world, if I can use that term, then we can use all the tools it affords us, all the tools it gives us that are at our disposal. So let's talk about min, max, and standard scalar. Which one would be better to use? And frankly speaking, it's really hard to know before we do anything which one will be better. It's hard to know beforehand which one will be better. But there are a couple of things we can kind of make sense of it. In fact, scikit-learn goes into this. Scikit-learn scalars. There's a whole page talking about all the different ways we can scale the data. And I want to point out to a little summary. Let's see if I can find that. Pre-processing, compare the effect of different scalars. So here we can read the pros and cons. But the problem with the min-max scalar is that what if we have outliers in our data? If we have an outlier in our data, it's going to control what is the max and the min. So the problem with the min-max scalar is that it's susceptible to outliers. Standard scalar, while you can argue, still has controlled by outliers, you're calculating the standard deviation, it's not going to be as affected by just some random point. If in min-max scalar we just have a random point that is really high or really low, it's going to set the scale. So scikit-learn argues that standard scalar is very sensitive to presence of outliers. I would somewhat disagree. I would say it is susceptible. I would not even say very sensitive. That's just a very hard. I don't quite agree that standard scalar is very sensitive. However, However, I get here that it cannot guarantee balanced feature scales because of outliers. I get that. But it's not as sensitive to outliers. So if you have outliers, or you suspect you have outliers, and you don't do anything about them, min-max scalar will suffer. Standard scalar will suffer as well, but not to the same extent as min-max scalar. So you could, right? You can go through here and kind of look for one that matches your fancy, but really the only way we're going to know for sure is if we run an experiment and really determine which one we think will do better. And let's get into that. Let's actually run an experiment and learn which one we think will do a better job. So in short, min-max scalar is more susceptible to outliers. Standard scalar still, but not as much as min-max. But the only way we're going to really know is we conduct the experiment. All right, I see someone have a question here. Is why do we use polynomial features in pipelines? Why do we use polynomial features in pipelines? Let's see. Why do we use polynomial features in pipelines? It's not. I would sort of disagree with that statement, right? We don't necessarily. There's nothing about polynomial features that makes us use them in pipelines. You can think of it as just a transformation, a transformation that we have access to. So your question is, why do we even use polynomial features? Let's go into pipelines. So now that I have my data, x of t, then I could create my predictor from sklearn, linear model. Let's import linear regression. I'll create my regressor, linear regressor. And now I can say regressor dot fit x of t and y. And now I have fit my regressor. I have fit my regressor. And this is a linear model. In other words, a linear regression model, the way it makes predictions as it follows this linear behavior. It says that our features are linearly related to the label. And what we need to do is we need to take the data and learn and determine what are the best set of beta coefficients. So when we train a linear regression model, we're trying to learn what are the best set of coefficients that we need given the training data. So now that I fit it, I can say my regressor, and those coefficients, those beta coefficients, are stored in a variable called coef. And the intercept is stored in a variable called intercept. There it is. So that if I want to then use my model to make predictions, I can say regressor.predict, give it my data, give my data. So a two-step process. I scale and then I predict. So what if I accidentally say predict of x? What did I do wrong here? And why is that a problem? Right, so we're scaling the features, right? We scale features, and we're trying to predict the home price. We go back, this is a housing data set. This is a housing data set that we mentioned yesterday. So every column is a characteristic of the house. And what we're trying to predict is the home price. Is it because X is not, yeah, exactly, right? This is a very common mistake we might make. If I look at our workflow, we're going to scale the data, and then we make predictions using the scaled data. Notice we have a problem here. Is we scale the data and then we use the scaled data to make predictions. We cannot skip. We cannot just take this stream and skip here. We have to follow through the transformation step. So it's a very common mistake that people do is that they'll say predictive X instead of the transformed one. And this is just a two-step process. One transformer followed by one predictor. It's a two-step process. Imagine if I have a three-step process, a four-step process with some of those stages are occurring in parallel. It's become very confusing for me to keep track of things. It's going to be very difficult for one to keep track of the intermediate transformations. So there needs to be a way I can take this workflow and wrap it as a single estimator object. So let's try that out. Let's solve this using the pipeline class. So from sklearn, pipeline, we're going to import a pipeline class. And a pipeline is just going to combine our steps together, and it's going to behave as a single estimator object. It's going to keep track of all the bookkeeping for us. It's going to keep track of all that annoying bookkeeping work for us. So let's create that out. Create my model. And now I'm going to give it a list. I'm going to give it a list. And I'm going to give it a list, and each element of this list represents a single step in the workflow. A step is given as a tuple with the name of the step followed by the object itself, the estimator object itself. So my very first step, this is a list. My very first step is a tuple. It's a tuple where I'm going to call that step scalar, and the estimator is this standard scalar. We haven't done any this. We haven't talked about the concept of training and testing just yet, but we'll do this in our experiment. My next step is my regressor, and then I will give that step there. So notice I have a two-step process. Scale, regressor. Now I haven't done anything just yet. I've just simply created the object. I give it a list of tuples. Each step is a tuple. The 0 index is the name of the step, and the 1 index is the estimator object itself. Any questions people have before we start implementing this pipeline? Okay, so I did. So let's go ahead and fit it. And now to fit it, I just simply called model.fit X and Y. It will handle the intermediate transformations for me. So in other words, I give it X, it will train, it will fit the scalar, transform the data, take the transform data and fit the regressor, and then use that regressor, and then train the regressor. It will handle the steps for me very nicely, just a single call to fit. We can create scalars and a scalar. Does it mean that the new variable called scalar should learn all the properties of the standard scalar have? When we create scalar, standard equals scalar, does it mean that the new variable called scalar should learn all the properties that scan out? So what this means when we do something like this here, when I do something like scalar equals standard scalar, this here I am creating a scalar object, so that with that object I can train. So it's a class object distinction that we learned in Unit 1. In the sense that we have a class which is a definition, an outline, and we create objects of that outline. So now we create the object, that's what gets fitted, that's what gets trained, that's what learns from the data, the actual object, not the class. Can you please take some time, explain the pipeline? So what I'm trying to do here is I'm trying to avoid the following work. I'm trying to avoid the following process. And I can sketch it out. I can say x of t, and I can say regressor I'm trying to avoid this work. So I'm trying to avoid individually training the steps. And I want to avoid keeping track of those intermediate transformation. Notice how this is, I create the object, I fit and transform, I create the regressor, I call fit. So then later I can just say, so this is just a two-step process. You say, oh, it's not too bad. But imagine if it's a three-step process. Or imagine there's several processes that are occurring in parallel. We're going to lose track of things. At least I will. At least I will lose track of things. So we want a way to wrap this all together nicely as a single object that will handle this for me. That's the motivation why I want this pipeline. So that's why we have to import pipeline. Right? That's our motivation here. I can do this manually, but this is going to be annoying. It's just going to bloat my code, harder to keep track of. All right, I see Shaymar popping up here. Welcome, Shaymar. And what does fit mean? Fit means to train the algorithm. Fit means to train the algorithm. We fit it, so then we can then use it. When we fit an algorithm, it learns from the data. So then it can take what it learned from the data and make predictions. That's what it means to fit. So it can learn from the data, so it can make either transformations if it's a transformer, or make predictions if it's a predictor. So when we call fit here, what it's doing, it's going to take the first step. Takes the first step and calls fit and transform. It takes that intermediate form and fits the regressor. So I'm going to go ahead and do something here, which you probably have done earlier. and that is create a train test split. So in machine learning, in order for us to properly create the models, we need to train them on training and evaluate them on testing. This makes sense, and we'll have videos that go into this, so we'll just kind of gloss over, just briefly talk about it here, is that if I'm trying to teach you something, I got to make sure that my test isn't the same questions you used to practice, right? If I'm trying to teach you some concept in math or grammar, and my test is just the same questions in your homework that I gave you the solution to, then we're going to run the risk that you just memorized. So we train on train and we evaluate you on test. So this function here will do the splitting of the data into a train and test. Test size should be 0.2. Okay. And we're going to say, let's split the data so that 80% is for training and 20% is for testing. Very common, very strong, very common convention. We'll reserve 80% of the data for training, and we'll keep back 20% for testing purposes. So I'll just go ahead and change this to X train and Y train. And now, if I want to make predictions on the test set, I can just say X of test. I don't need to handle the transformations. I don't need to handle those intermediate transformations. It's going to handle it for me automatically. Previously, if I didn't do a pipeline, I would have to, this is without pipelines, I would say X of t test t scale transform. Then I would say regressor predict X of test t. So previously without pipelines, I would need to remember to transform any data. It's not predicting STDs and means. We're not. We're not predicting STD and means. We're trying to predict the home price. We learn the STD and means from the training data so we can apply the transformation. If I look at this question here, when using a training set, we do both fit and transform, but with the test set, we only transform and not fit. Using pipelines, we won't be doing the fit and transform on the test set. With a test set, you don't fit with a test set. You don't fit with the test set. You still need to transform it, but you don't fit with it. So we go to our workflow. If I want to apply a prediction, I have a new data set, X of test. I need to make sure that it runs through all these transformation steps. I don't just skip to the line. So a pipeline will handle all that for me. So notice how the pipeline takes care of all those intermediate steps. Questions people have. in what case do we decide to use a pipeline? We use a pipeline when our workflow has more than one step. When our workflow has more than one step, we're going to use a pipeline. So, more than one step, use a pipeline. If it's just one step, you don't need a pipeline. I'm being asked, what is an ETL pipeline? Well, ETL just stands for, I'm not saying just stands for, but ETL stands for extract, transform, and load. It's just a way of saying that there are a set of things that one must do undergo with data. And the pipeline that we have in scikit-learn is not exactly what people say. So ETL pipeline is a general term. A scikit-learn pipeline is a very specific thing. So scikit-learn pipeline is a very specific thing of stringing together transformations and a single predictor. In some sense, it's going to behave like an ETL pipeline. An ETL pipeline is basically someone has configured a set of steps to work with your data. So you can think of a scikit-learn pipeline as a very special case of an ETL. An ETL is just a general term that refers to a series of steps that you can kind of automate, so you can have in raw data, and it undergoes through that cleaning transformation process. So in some sense, the name pipeline wasn't sort of chosen accidentally. Okay. Now we haven't quite answered the question about which one is better. Which is better, min-max scalar and standard scalar. I guess we'll have to pick that up tomorrow, and we could run an experiment. But now we are better equipped to run that experiment, because we're going to use pipelines to handle all the dirty work for us. We got a couple minutes left, so I don't want to get into that now because it's going to take a little bit longer. But any quick questions we'll have before we wrap up for today? How is the price? Ramsey's asking a good question here. Why is this house worth 2.7? I think it's worth 2.7 is because the units or labels are measured in tens of thousands of dollars. So that the home price is really $27,000. And this data set is from the 80s, I believe, when home prices, $27 for a home. So I think 70s and 80s. It's a rather old data set. So nowadays it'd be 270,000. So that's why. It's because the labels is reported as tens of thousands of dollars. All right, so we are out of time. And what is a pipeline? A pipeline, in short, is a way where we can string together multiple stages so that we can better handle the transformation processes. And what is the difference to select K-best and PCA? You'll have to bring that up later in a different office hours. But with that said, everyone, take care. Have a good rest of your day. Don't forget these are posted online, so you can always watch them later. And see you back